Hello, everyone. The purpose of this meeting is I'll be going over the SNBI Collector. I really wanted to have this meeting so that way we can kind of discuss and go over SNBI Collector as a whole. I've gotten a lot of questions internally and externally about SNBI Collector. What does it do? How does it do what it do? So for this meeting, I want to go over everything from a developer level for technical folks and non-technical folks for business and all that sort of thing. So hopefully this is the be-all end-all video for all of this, and we're talking about a year of development all in one video, so there's quite a lot to go over, and I'll get started. So first of all, who am I? I'm Eddie Hartman. I'm a software developer at Mayvue. That's my contact info. So what are we going to cover today? What is SNBI Collector? Why is it beneficial to users? What need does it fill? How does it work? The typical workflow that users have, an overview of the architecture, hosting and pipelines, observability, analytics, AI and machine learning efforts, and work going to platform and other projects that we have going on. So starting off, what is SNBI Collector? It's a PWA, or a progressive web app, for users to create and perform CRUD, which is create, read, update, and delete operations on bridge data that works online, offline, on any device, and syncs all data to and from a central sync server. So it's quite the mouthful, but that's the one sentence pitch. On the left here, you have the app in a database, and on the right, you have a database in the server, which is also going to perform some of the AI and machine learning type of calculations that we're going to be talking about later. So what are the benefits to the user? Well, number one is it's going to follow the new coding guide, and this is the landing page for it. The slides will be downloadable, and they're already shared with the team internally. But the old coding guide was over 100 pages, which is already pretty long and technical. The new coding guide is over 356 pages. So if you read a page a day, you still won't be done in a year. So the most important benefit is just filling the gap while users need to transition from NBI to SNBI. And the SNBI transition timeline is in the memorandum that is available at this link. So we needed to cover a gap in the timeline before BRM 7.0 in the next version of mobile. So if you look here, here's the timeline. I'm going to start all the way on the left. So here you can see SNBI was posted. Then the FHWA transition tool was posted. And these are within March. SNBI Collector development started around July. SNBI Collector went into production. I'll skip that for now. If we look here, we have BRM 7.0 release, which is still underway right now. And we're kind of in this area. The first SNBI submittal that is possible is in March of 2026. This is a halfway transition where you can submit data, but it needs to be transitioned using the transition tool. So this is the first time that you can submit using the new SNBI data. And by this point over here, March of 2028, you need to have 100% SNBI submittal. But one of the things that we noticed that wasn't really being talked about a lot is that some bridges are on this 4-year inspection cycle. So if you look at this timeline, we knew BRM 7.0 was going to come out around this time, but some bridges are on this 4-year inspection cycle, so you would have to start collecting this data in the new SNBI format before BRM 7.0 would be available. So we realized that we had this gap that we needed to fill, so this tool was created in order to start collecting that data so users could fulfill their need of collecting this data and reporting it within that time. So some other benefits. Clearly marks field transition statuses with color codes, and the overall goal is to go from red or yellow to green, and each of these have a different meaning. So green is that it's clean, yellow is that it's a computed transition, and red means there's no transition. And on the right there, you can see about 2/3 of them come over as clean, the field data. From NBI to SNBI, a sixth is yellow, and another sixth has no transition. It allows users to assign bridges to inspectors. SNBI Collector is very easy to use. Simple and clean was one of the principles to kind of keep in mind while designing it. Try to make it very, very easy. And the reason for this is that the new coding guide is overwhelming enough. Again, it's, I believe, 366 pages for the coding guide with errata. So that's a lot of technical jargon and a big leap to go from the old coding guide to the new coding guide. So we wanted to ease into that transition as much as possible. It's also a fully managed application instead of spreadsheets or in-house solutions. Updates are automatic and seamless. There's no database scripts to run or no need to install an update. You simply get a pop-up and refresh the page. We try to take care of things as much as possible, make it as easy as possible for our users. So you also have the ability to validate data against the FHWA rules. FHWA has their transition tool, but they also have a bunch of rules that exist for validation to make sure that the data being collected is in the format and everything that they expect. When the coding guide gets updated or bugs get fixed, we automatically handle the changes for them. So in the application, again, the app updates are pretty seamless. We take care of any changes or anything like that, and we found some issues with the SNBI rules. So we adapt the application to fit that as best as we can for the users. So for example, there was an errata that was posted on May 9th of 2024 that contained at least 17 substantial field changes. One example being changing field BEP04 from a 2-digit number to a 15-character string. Some fields even needed erased because of options being changed. So for example, there was a field where, say it was value of X. X no longer meant X. X now meant Y or Z. So now when we updated that, we had to erase that data and have the user re-enter that because the rules for that guide actually changed. That would be very difficult to handle and manage with any in-house solution or any type of spreadsheet. So we try to take care of that as much as possible. And it was an automatic and seamless update. We deployed an update that updated the database and app automatically and had 0 issues coming in from users. We had a couple tickets with questions. Typically, it was the type of thing where, hey, just go read the release notes. But there were no substantial issues or anything like that coming in. It was fairly automatic and fairly seamless. So some things to keep in mind. Users may not move to 7.0 right away. They may wait for bug fixes like 7.1, need time to prepare internally, etc. So even that timeline that I was talking about before, just because 7.0 is out doesn't mean that they're going to immediately go from 6 to 7. Maybe they still need to use this time in order to do training, kind of get caught up to speed and do that sort of thing. We also wanted to just get users used to mobile. We're going from like a web application that didn't really work all that great on your phone to now being run everywhere type of service. This also has a change log for seeing what has changed or for undoing a change from the users. And it makes it easier for us to get into 7.0. So if you're running BRM6 and you have NBI data, you can put it into SNBI Collector, update it to SNBI, and then we can move that data from SNBI Collector to BRM7 so that you have some updated data that you're collecting in the meantime. And we will help users get their data from SNBI Collector to BRM 7.0 as part of your license. So what's the typical workflow for a user? If you want to try it, you can follow along. For those watching the recording externally, you won't be able to log in or anything like that. Contact us for a demo. But for us internally, I've already posted the username and password. This is the link. If you want to go to this site, you can sign in and play around with the site and try it out if you want to follow along. So first of all, you log in, and Auth is using a standalone Newman instance for those external. Newman for us is just a authentication server that we're using. So just paste your the demo username and password into the chat. So the typical workflow is to go to the download page on the right here, download a bridge, which you can see all the way on the right, edit from the bridge list page, validate it using the bridge list page or the validation page, upload it back to the sync server from the upload page. So step 4 is optional. Maybe users don't want to validate, or maybe they just are trying to get certain data in there. But if they want to, they can validate that data to make sure it's all correct. So here you can see me just signing into the app. I'm going to the setup URL, which is very nice for users because this is automatically going to set up the application for them to be connected to their site. You can see I got a green confirmation there that I actually hit the correct sync server for that individual user or DOT. So now it's just going to log me in. I log in via Newman. Once I'm logged in, the database is already being made within the browser. I can then go to download my bridges. So now I'm going to download this one bridge. I can go to the bridge list page. I can edit this data. So here I can do a quick edit just within the grid itself, or I could go to the edit page, which will give more of a form-like feel. I just made that edit. It highlighted that it was changed. I can now validate it, and there's a lot of validation issues here, but there's none against that specific field that I just changed, just to make sure that it's not going to cause any type of issue. Then I go back to the upload page to be able to upload this and sync it back to the server. And now that data is available and up there. And then if I go back to the download page, I can now see that updated version of the data there. So architecture overview. I've gone over this quite a bit with the developers. I'm keeping it high level. I've done other presentations on this. If you want to see those are available. But it's a Blazor WASM front end using Mud Blazor for components and theming, SQLite WASM helper for database for using the database in the browser, with an ASP.NET Core backend, which is helpful because we're using C# in the front and back end. So the code can be put into a library and reused for the server side and the application side. It's using Entity Framework Core with SQLite for the database in the front and back, which again, all of these C# models, all of these database scripts, everything can be reused in the front end and the back end, which is great. So therefore, again, the code is reusable everywhere and even exported to libraries. And we're using Fluent validation for the validation, which again, front end and back end is the same. It's great. So using the same DB and front end and back end code allows for some neat debugging tricks. So this is a screenshot from the settings page, which is a hidden page, but users can access it if we need to whenever we get support tickets. And also there's the support widget within the app itself. So creating tickets and getting support is very simple. But here, what we can see is number one is being the ability to clear all the data. This is more used for debugging or internal development, but if there was some type of issue where we had to absolutely reset the database data on the user side, we have the ability to do so here. Number two, we can download the SQLite database straight from the client and send it as an attachment in the ticket. So since there's a widget within the application itself that supports attachments, you can download the database and send it to us in the ticket so we can just immediately debug any issues. There's no talking to a DBA to get a backup of the database or doing anything like that. You can just do it from within the app. So number three, you can export the data to FHWA SNBI JSON format, which is supposed to be a standard format. Number four, you can restore the database from step two. So if we got a database from you and needed little fixes or replace some bad data or do something like that, we can then upload it and restore the database on your application right from within the app. So that way you can download it, send us the SQLite file, upload it, we fix it, we send it back to you, you just set it back up. There's, again, no contacting a DBA or doing anything like that. And this is all on the client side, so the server side where we're taking frequent nightly backups and doing all that sort of thing is also not affected. And then 5 and 6 are just for setting up new sites, typically for development, but you can upload an SNBI tape to import data for a bridge, or number 6 is to transition from an old NBI tape to new SNBI format. So front-end and back-end database schemas come from the same base with only very minor differences for the server versus the back-end. An example being bridge assignments are saved on the server side, so that way you can't just assign a bridge to yourself from the front end and then make modifications to that bridge. And it makes it really easy to copy data back and forth. So using Blazor in the front end was actually pretty serendipitous because FHWA for their transition tool actually used it as well. So it was a architecture that I was familiar with, and I was able to view, kind of understand, update, and work with their transition tool code to modify it and get it working for us to understand how they're transitioning from NBI to SNBI and create a version for us for our app. So hosting and pipelines. Remember, there's two apps. The SNBI Collector, which is the application that you actually hold in your hand, and the sync server, which is hosted by us that the data kind of goes to and from. So number one, on the right here, I have a screenshot of the Azure DevOps pipelines. You can think of these for the non-technical folks as just like scripts and automations to automate all of the work and all of the things. So number one there, we're building both apps. So we actually have, think of like an exe to run. Number two, deploy the front end to IIS server. So we use IIS, which is just a hosting server. And so the front end, that is the SNBI Collector application, the part that, again, you hold in your phone or go to on the website. Number three, you can deploy a single or new backend to an IIS server. So if I'm spinning up a new DOT or agency. But number four allows me to deploy all of them, and it updates all of the existing sites. So in parts 5 and 6 there, you can see that all of our dev server setups and all of our prod server setups. When I run number 4, it's going to update everything all at once. So we do frequent updates with lots of deployments, and they're all seamless because as soon as the application starts up on the front end or on the server side, it automatically migrates the database to the latest version. So there's seamless updates. And that's it. So it's just that simple. And backups, all we have to do is copy a SQLite file to share file, and that's how we're performing our backups. And SQLite is nice in that it's just like a single file that you kind of copy and you're good to go in terms of having a backup. So since it's PWA with offline support, the SNBI Collector app doesn't have downtime like normal web applications. So we can do these frequent updates because if the user is using the app while I'm deploying an update, they probably won't even notice anything, because even if it can't reach the server, it's still going to be able to run and operate like normal. We don't really have to worry about scheduling downtime or scheduling deployments and that sort of thing because it's pretty seamless. It'll update itself and we're all good to go. So you're telling me that we can store all of this data offline and it works offline, but where does all of it actually go? So it's stored in various browser APIs that can be accessed offline, such as the app cache, which is different from your regular browser cache, an API called local storage, and IndexedDB. I know that I'm getting a little bit more technical. Just stay with me. We'll explain it in a little bit. And what makes it a PWA? It uses what's called a service worker that can be installed, handle requests, and provide offline support. So the way that a PWA works is when you go to navigate to another page, it'll make a normal browser request like you do with any other website, but there's this thing called a service worker that can intercept that request and say, hey, can I respond to this request with data that I already have stored offline? And in most cases, the answer is yes for us. So that's how it works offline. So there's other APIs like notifications that are available with using a PWA. Here's a breakdown of some of our hosting pipelines. If you're on the application right now, you can just hit F12 and go to the application tab. Again, we're getting technical, but I'll keep it high level and we'll kind of break it down together. If we look over on the right here where the screenshots are, number one is that application tab. Number two, you can click on to see and view the service workers. And then number three, in the highlighted area, you can see that the service worker is installed. The status says it's running and there's no pending updates, so there's no issues or anything like that. Number four is the auth setup storage, which is setting you up to log in. Number five is Matomo Analytics. Matomo is a tool that we'll talk about a little bit later that is for front-end analytics, but this is where offline data is being stored. So when a user is offline, we can still track certain behaviors and things like that. Number six is where the database is actually being stored, which is in the cache storage. Number seven is where the Blazor WASM framework is being stored. So that's all of the Microsoft stuff. And then number eight is the SNBI Collector app itself. And so if you click on number 8 there, you can see here on the left is a screenshot of some of the files that you might see. If you see number 1 there, it says predictions.csv. That is going to be the file where we store all of the bridge data deterioration predictions, for example. So we'll talk about that a little bit later. But that's where the application itself and all of its data is being stored. So the backend sync server has this thing called health checks. Just says, hey, am I still good? Yep, we're fine. An Uptime Robot hits those health checks to determine if the app is healthy. If not, Uptime Robot pings the 911 channel for the SNBI Collector side specifically, sends an email, and sends out a call if necessary, so we can make sure that everything is up and running at all times. Now, I'm going to talk about a thing called observability. It's very different than the health checks, but they kind of sound similar in that health checks are, hey, let's make sure that this is working. Observability is more about what is actually going on and getting into the details of what's currently going on. It goes well beyond just health checks. So we get to see what's going on with the app or a collection of apps remotely without logging into the server and manually digging through the logs. That's a huge help for developers like me, so we don't have to remote into the server and check all these text logs. We can log into a website and just check all of the logs in one place, because if I hadn't mentioned this yet, but we have over 15 different servers that clients are using. And so this is all centralized into one place. That way I don't have to dig through all these different folders to see specifically what things are going on. Observability typically consists of log metrics and traces. And logs, for all of the non-technical people, you get to see everything going on with the server via text, which is like error details, who changed what, what's going on at this time, that sort of thing. Metrics are usually numeric data, such as active connections over time. Traces are information flow to and from the server. So what do we have set up in terms of observability? Well, on the development side, we have this tool called Aspire that lets us see this information locally when developing. So here we'll have an example of number 1, here's a log. So this is what a log looks like in Aspire. Here's a trace, which is more of a time-sensitive network, basically tracking the information going to and from the server. And then number 3 is going to be a metric where we're looking at the memory usage. So this is more the visual numerical graph over time. And in this specific case, we're looking at the memory usage of the server. And so for observability, we're using Grafana for production, so that way we can observe all of these applications at once, all of these different servers that are running in one centralized location. And on the right here, you can see an example where we're seeing the usage by the user by the route. And this is helpful for people like Ian on the sales team, so he can see who is doing what at what time. We can see what kind of traffic we're getting and that sort of thing. So analytics. Analytics are kind of like observability, but they're a bit different. This is more for tracking things on the front end. Observability is more for tracking things on the server side and what's going on in the server. So for analytics, we get to see at a glance who is visiting, from where, from what device, what browser are they using, the loading times, the user flow, all of that sort of thing. Whereas for observability, we're seeing things more like what records were written, how long did the response take, different things like that. And this is provided by Matomo and works online and offline, which is one of the bigger selling points for us. And here's some examples of what we're looking at. So on the left, we have a flow diagram where we can see a user landed at this page, then went to this page, then went to this page, and that's like a typical flow. In the middle here, we can see what operating systems they're using. On the right, we can see the browsers. And then on the bottom right, we can see a visual representation of the browser usage and sharing. One of the big selling points about the PWA architecture of this is that it runs on any browser anywhere. And here we can show that. And it's kind of neat to actually see who is actually using what, because it's different between the fact that this can run anywhere versus it just being a web app. So we were able to collect some of these with other different systems in the past, but now we're actually getting to see a lot more granular what people are doing with what devices. So here we have a dashboard. This is just a user list, and we can see individual user info. So on the left, you have the dashboard, which obviously gives you overall info. The user list there, where I can see like for individual user, how many times have they visited, how much are they interacting, which is the actions breakdown. And then on the right, if I click on an individual user, I can actually see what they were doing, what device they were on, all that sort of thing. And then on the bottom right here, you also have a live visits map. The circles that have another white circle around them are the locations of users that are actively connected and using the application right now. Not only do we get a map that shows the users using the app in general, but we can also see all of this information essentially in real time. So what are some of the AI machine learning aspects of the app? 4 different projects were done in this order chronologically. So there was the SNBI Guide PDF chat, NL to SQL or AI data chat. And I'm going to explain this one first because it's one of the more complicated ones, but it helps set the tone and how everything else kind of works. There's the ML deterioration modeling and genericized document chat, or the Mayvue AI assistant, or the Maya document chat. So NL to SQL. So I've done a presentation on this. It's available at the end of this presentation as well with a link. I did a presentation to Microsoft. I also did a presentation at the AI Summit here in Pittsburgh. So if you want to get into more details about this, you can, but this is just going to keep it at a high level. The idea is natural language to SQL. So in this case, we're going to create a SQL query to answer the user's question. They're going to ask a question to the database that's, hey, how many of my bridges have this element? And so it's going to create a SQL query that can answer that and display those results. This works because the database for us is on the user's device and in the actual backend. We can run a query that is being AI generated and feel confident that it's not going to mess with our backups or anything like that, because it's going to run on the user's device. In case there's like some catastrophic event with the AI where it somehow modifies data, which it's not programmed to do, and we were never really able to do that in any of our testing, we still feel confident because nightly backups and everything like that are happening on the sync server on the back end, and there's no running of those queries on that server. For example, which bridges are curved bridges? Answering this requires knowing that column BG12 indicates the deck geometry, and the options are CU, CP, CK, and N. For anybody who even writes SQL code, just knowing this information is still hard to create an actual query for this. So it's especially important for the AI to be able to understand this and create a query to answer this. So here's another video example. So here we're setting this example up where we set a curved bridge. I'm going back to my bridge listing page, checking again that this is the curved bridge that I'm looking for. Then I go to the data assistant, ask it the question, which of my bridges are curved bridges? In the back end, it's creating a SQL query to run, and then it's going to display this result in the front end of all of the bridges that are curved bridges. And there we were able to confirm that this is the correct bridge. how do we actually get there? Well, obviously, the first part is the user's going to enter a question. Question goes to the sync server. The server verifies that it's a valid question. So it's going to remove questions that are things like, what's the most popular breed of dog? That has nothing to do with us. We don't want you to use the AI chat for anything and everything that you want. It'll remove that type of question. The sync server is going to fetch the database schema with additional context around things like, what do these columns mean? And it'll add schema to the prompt along with the question. If you're familiar with any AI chatbots like ChatGPT, we're basically doing the same thing that anybody else would do and just entering in a question and having it spit out an answer, but we're supplying it a lot more information about what does our database look like, what's the question, and extra information around that question so that way it has the ability to answer it. And it's doing it by performing this thing called RAG, which is known as Retrieval Augmented Generation Pattern, to retrieve extra relevant data if needed. And it gets a query back and runs it against the database on the device. So for more detail, this is using semantic kernel. Again, more details are available in the other presentations, but this is an open source AI orchestration platform provided by Microsoft. It's using semantic memory, which is another tool. It's for embedding and memory storage within semantic kernel, so that way we can store information about the SQL schema and the database itself, so that way the AI is able to answer those questions. And this contains the specific information about those columns, so we can fetch it if it's relevant for using that RAG pattern. And in our case, we're using OpenAI using GPT-4, but semantic kernel is a layer of abstraction, which means that we can switch to any other model, any other tool. So if we want to use Claude, Meta AI, whatever else, we can switch to that because semantic kernel is basically letting us configure it and set it up in any way that we want to be able to use it. And the schema is defined in a YAML file. More details about semantic kernel itself. It's an AI orchestration service that takes information such as the API key to set up a service in .NET to send requests. It's basically going to automate the idea of writing out the query and then sending it to ChatGPT. The initial prompt is to screen the objective and make sure the question is relevant to the data. The second prompt says, generate the SQL query in our flavor of choice, which in this case is SQLite, and build something that can answer the question given by the user. This is doing what's called prompt chaining, where we're sending a first prompt that says, is this question relevant? Should we answer this? And then the second prompt is, okay, we know that the question is relevant. Please answer the question now. And additional information is fetched from kernel memory to help define what we need. For kernel memory, every table and column has a descriptor, which is more of a human-like descriptor. So in this case, columns have names like BL01, which we know what that means based on the coding guide, but any human being reading this, and in this case, any AI reading this, doesn't know what that means. So in this case, that means state code. It's an embedding store for retrieving data relevant to answering our question. So for example, if we're getting state data, we need to know all of the key value pairs. So state information is stored such as like 1, 2, 3. Those are the keys for what the state means, but the AI doesn't know that 1 means this state, 2 means this state. So as another example, if we talk about BAPO1, which is bridge condition, it has values G, F, and P, meaning good, fair, and poor. But if you ask it the question, I need to know what bridges are in good condition in PA, it needs to know, hey, BAPO1 is bridge condition, BL01 is the state code, and then in another layer, it's getting, okay, in the state code, these are all the keys for all the states that it needs. And in bridge condition, it's saying these are all the keys for bridge condition that it needs, and it can combine all of that information to generate a query and run it. Before that, we actually made the SNBI Guide PDF chat, but the NL to SQL thing was a little bit more in depth, and I was able to kind of explain that. But working backwards here, the idea is that we're going to read a PDF, break it into chunks or paragraphs, and create these things called embeddings. Embeddings you can think of as just like nuggets of information. They're basically like paragraphs, so that way we can search and provide that RAG pattern to get relevant information and answer questions. So we take the user question, perform a similarity search to get relevant information from those embeddings to then put into the question that we send to ChatGPT so we can get the answer. So again, we perform RAG where we give ChatGPT an initial prompt, context from the PDF, and the user question, have it generate an answer. This got expanded upon by Stephen Panava. And this part, we wanted to genericize it and make it so that way a user can upload any PDF that they want. The initial version just worked on the SNBI guide, coding guide, which we provided to users because there's so much information in that coding guide. Maybe a user's out in the field, doesn't quite remember exactly what they need to do. They can ask a question to the AI and get a quick answer while they're in the field. But for Maya, we wanted the ability that the user can upload any document that they want and still ask questions to it. So the user can upload a document, it'll read a PDF or a docx, like a Microsoft Word doc file, break it into chunks and create embeddings, perform operations similar to the SNBI guide chat to answer questions, and created tooling for making embeddings from any PDF using semantic kernel, kernel memory, and OpenAI. So the benefit of using this over other dedicated tools because they are out there. There's ones that are like PDF chat, PDF assistant, whatever, is that when we were researching this and looking for other tools that we could buy instead of build, they weren't all able to cite their sources. If you ask an AI a question, there's a lot of hallucinations and other things like that happen. We don't want to be giving users hallucination answers. We want them to be able to actually double check the AI's work. On top of that, there's some that do that, but they also weren't able to ask questions and cite sources from multiple documents. In our case, we're allowing the user to upload their user handbook and the coding guide, and they can ask a question that it needs to know information from the user handbook and the coding guide to be able to answer. In this case, you can just have the SNBI guide for the bridge, but there's other information that the user might need that it can ask that question, and it'll cite sources from both of those documents so the user can double check those. For example, what does our handbook say about filling out field BID02? So in this case, it needs to be able to look up information in the handbook, and it needs to be able to look up information about that field of BID02, which is just bridge name. Grabs context from the SNBI guide for BID02 and looks into the user manual. And then here's like a video example again. Here, I'll let this video play out. This is what the chat looks like. On the right there, you have the documents. The user can upload their own documents, but here we can kind of create this chat. So right now I'm typing in the question, what should the field BID02 contain? And then it's going to answer here, that should contain the bridge name. And then it's going to cite this source. I can click on this source and actually see where it got that information from in this document, so that way we can actually double check the answer. Moving on. So machine learning deterioration. We also wanted to be able to do predictions based on past inspection data. What's the condition of that bridge today going to look like? Because they're going out and doing inspections, but hey, let's get some of this information in there. So we grabbed all the NBI data for all bridges and states. We filtered the data by reliable deterioration curves to help model and predict when bridges will deteriorate. And then we ran that model against every bridge, and through the model created a lookup table that looks up the deterioration prediction and shows the result to the user when they're doing these inspections. So here, there's another video where you can see, hey, it's going to open this prediction result. You can see the prediction result, and it'll do for deck, super, sub, and it kind of gives like a visual example of, hey, we think that this is really going to be deteriorated, or hey, it's probably healthy. It's probably not any lower than what it already is. And then Luke, this is your slide if you want to go ahead and speak to this.
So at Mayvue, we're implementing a strategic shift towards a data science perspective. Previous approaches to predicting bridge deterioration relied heavily on rules and heuristics, but now we've developed a machine learning algorithm to forecast bridge deterioration times. Given that the Astroware bridge management software manages thousands of bridges and over $1 trillion of assets, what is the value of each percentage point improvement in deterioration projections? Also, given that the estimated 2022 total cost in dollars to maintain bridges nationwide was $31 billion, what is the value of each percentage point improvement in the quality of budget allocation decisions? Today, I'm excited to introduce the incorporation of our machine learning model into the SNBI Collector, achieving a 25% improvement in bridge deterioration projections. We've used our machine learning models to make predictions on all bridges for the superstructure, substructure, and deck condition. For Mayvue and its clients, these data-driven insights will provide a practical advantage, helping to better predict deterioration over time and ensure that the expenditures are directed where they're needed most. While our model will not be right all the time, especially in a field as complex as bridge management, where environmental factors, unexpected stressors, and wear can all influence a bridge's condition in unpredictable ways, yet our model represents a significant advancement in bridge management technology, which, when applied consistently over time, will produce better outcomes in bridge maintenance and budget allocation.
Thanks, Luke. This obviously wasn't a one-man show. There's a lot of work that went into these things, and it's great to have other contributors into these projects. We used a bunch of libraries. We always use open source libraries and things like that. But as Billy likes to say, how are we giving back? With the research that we did, we were able to give back in some cases. So this is going back into core, going back to open source, that sort of thing. Number one is just the SNBI tape models themselves. It's a library that's going to be reused in core. This is just for setting up the actual JSON format for the SNBI tape itself. There's also the SNBI tape generator. From number one, you get all of these models in code. And then once you have those models filled out, we can create the actual tape that needs to be submitted to FHWA. So as long as we can fill out the models, we can make the tape. And this is just being reused as a library so that it's not just SNBI Collector benefiting from it. It's core, it's Icarus, it's whatever other projects that we have going on can all reuse this information. There's also the SNBI tape validator, which is validating against FHWA's rules. And this was already updated with the coding guide update. All of these other products, in this case, BRM7, is using this for validation, they're already benefiting from that work. So that way they can use the new and updated coding guide and its added rules to check and validate the tape. The SNBI tape validator has unit tests and make sure that the validations are accurate and are going to stay accurate, which again, any team can kind of contribute to that and add more tests or do whatever. And this was also updated with the coding guide update. There's transition code, which was the code that was used to transition from NBI to SNBI, and this was helpful for making the transition code in BRM from BRM6 to BRM7. The NL to SQL engine, which is that AI integration that I talked about, which can be used for Icarus, Platform, whatever other products that we want to use moving forward. There's the Maya document chat, which is another AI integration that we talked about. Some more, there's Aspire, which is set up as core and part of Platform now, so it's being able to be reused in BRM7 and Icarus. Open Telemetry, which is integrated into Platform for any app again, currently in BRM7 and Icarus as a reusable setup. Matomo, which is planned to get integrated into Icarus, but it's not set up right now. PWA Builder knowledge. Packaging and setting up the PWAs for App Store distribution actually took a lot of work. And so for applications such as Icarus, we can reuse the knowledge of SNBI Collector to be able to package up those applications and for any other application that we're working on. And also when working on this PWA Builder is open source, and I went through and updated some of the documentation because some of it needed updated within their setup as well. Grafana Cloud. So Grafana Cloud is set up on our servers now, so we can be ready for any app with sample code. And I worked with the Grafana.net dev team directly and got on the phone with them because I was having some troubles with the setup, and we worked through it together, and they were like, oh yeah, this is a bug. We're going to work on this. They updated their documentation and we were able to work through some of those things together, which is great because that platform is also open source. Mudblazer, we updated in-grid editing. So there were features that we wanted to be able to use that didn't exist in things like Mudblazer. So we added them. And then SQLite WASM helper. The ability to restore an existing database and the ability to automatically apply the database migrations, which is what's allowing us to do those automatic updates, didn't exist in this tool. We created them and we contributed them back to that library. So when I say that no one else is using this application stack in this way and no one else is using this architecture in this way, it's because we invented it. We're the only team that I'm aware of right now that does this in this way, and it makes it so seamless and easy for us to do what we do. And so here are some references and other things to look into. The NL to SQL Microsoft presentation is available there. If that's something that you want to look into, again, the slides will be available for downloading, so you can visit these links. The AI Summit presentation is available there. The Idaho SNBI webinar is available at that link, which is a user talking about using the application. So if you want to hear it from a user's mouth, you can go there. And Rob also did a part of that presentation as well. If you're internal, the SNBI Collector project is available at that link if you want to go look at the code. Everybody that's internal should be able to access that in terms of developers. So at this point, are there any questions? I know I went super long. Hopefully nobody fell asleep. If you have any questions, now's the time. Okay, so again, here's my contact information. If for some reason you don't know how to contact me, just wanted to throw that out there, and we're always hiring. Thanks for attending the presentation.